box fill. This is one, again, you're going to see this throughout the year. It's going to end up on the final. It's not going away, and it is really important, and it really applies to the real world install as well. As you're actually pulling wire in your career, you're going to need to be able to do this and be familiar with this. So in this case, we've got a little example where we have a 14-3 Romex coming in, 14 gauge 3 conductor. We have a 12-2 Romex coming in, 12 gauge 2 conductor. 14-3 is connected to a switch over here. The 12-2 is connected to a receptacle. We've got some internal cable clamps here. So if you guys remember from your reading, there's basically, we're going to add up all of our, what we call volume allowances for this little scenario, right? And there's different things that are sort of weighted differently on how many volume allowances we need to add in here. And here's a little chart, table 314.16b in your code book, that says what is the cubic inch volume allowance per conductor size, right? And again, if this seems a little vague, I encourage you to go back and watch the video that was posted on the LMS about box fill. That's a much longer video, much more in depth. But again, this is a general overview. So I stress, if you haven't watched those other videos and you need some help on any of these topics, go back and watch them. There's a reason I chose to make a video on those topics. This is a pretty high level topic, right? So the first thing we need to know, what do we need to, how do we count these volume allowances? Well, we count, let's run through it, right? A single volume allowance based on our current carrying conductors. So if it's a hot or a neutral, that's a current carrying conductor. We count a single volume allowance. What does that mean? If it's a number 12 hot or neutral, we count it as one number 12. If it's a number 14 hot or neutral, we count it as one number 14. Simple as that, right? So what I like to do is kind of make sort of tallies for each wire size. So I've got 14 gauge wire here, and I've got 12 gauge wire here that we have to deal with. We need to count these up separately, right? So first of all, how many number 14 current carrying conductors? So I'm not counting grounds now. That's not a current carrying conductor. We deal with that separately. How many current carrying number 14s? Well, I have a 14-3, so that's a dead giveaway that I have 1, 2, 3 number 14s. So I'm going to go 1, 2, 3 down here. I'm going to add 3 little tally marks. Let's do the same for my 12. Again, a 12-2 is going to have 1, 2 current carrying conductors in it, right? So there's your current carrying conductors. Now we have to think back for our grounds. For the grounds, the code reads, in a nutshell, we count a single volume allowance based on the largest grounding conductor in the box. So it doesn't matter how many grounds are in the box. We count a single ground based on the largest. Well, we also sort of have to know, or we've already learned, that a number 12 Romex has a number 12 ground. A number 14 Romex has a number 14 ground. Number 12 is larger than 14, so a 12 ground is the largest that we have in the box. So we're going to add an additional volume allowance down here for a number 12. Now let's look at the cable clamps next. The text tells us and the code tells us for a internal cable clamp, we count a single volume allowance based on the largest conductor in the box. These are, in fact, internal cable clamps. There are external cable clamps. That's not what these are. But if we had external cable clamps, we're not going to count anything. We're not worried about it. But because we have internal cable clamps, we need to add a single volume based on the largest conductor. Notice it doesn't say add a single volume for each cable clamp. It just says add a single volume. So even though there are 2 cable clamps in this box, we're only worried about 1. And we only need to add a single volume based on the largest. The largest is a number 12. So we're going to add one more number 12. Now one of the last things we have to sort of count up here are our devices, right? The code is going to tell us we add a double volume allowance based on the largest conductor connected to any one device. So in this case, we have 2 devices that we have to deal with. We have the switch, which has only number 14s connected to it. We have the receptacle, which has only number 12s connected to it. So we're going to add a double volume of 14 for the switch. So we're going to go 1, 2. We're going to add a double volume of 12 for the receptacle. So we're going to go 1, 2. Okay. So that is everything we're going to need to count. There are some other things that may need to be counted, but I can tell you on any of your tests, that covers everything you need to be aware of. There's all kinds of oddball things that honestly don't come up that often. Those are the things you need to be aware of, right? So what do we have here for our 14s? We have 1, 2, 3, 4, 5 in the number 14 column there. We have how many in the number 12 column? We have 1, 2, 3, 4, 5, 6 in the number 12 column, right? So now we say, okay, we have 5 volume allowances for number 14. We need to multiply that by how many cubic inches? Well, we check the table up here, 31416B. Number 14 is going to require 2 cubic inches per volume allowance. So we're going to say times 2 naturally is going to equal 10. And then down here for number 12, we have 6 number 12 volume allowances. For number 12, we're going to count 2.25 cubic inches per volume allowance. So we have 6 times 2.25. And that's going to give us 13.5. So now we need 10 cubic inches for the number 14s. We need 13.5 cubic inches for the number 12s. So we can simply add those together. So we need a total of 23.5 inches cubed to contain all of this stuff, right? So there's your box fill. This is a little bit of a complicated example because we have 2 different sizes, we have 2 devices, but that's about as in-depth as it's going to get. So if we can manage that, we should be in good shape, right? So last topic I want to talk about here is your receptacle spacing. How far apart can receptacles be? I want to stress, first of all of this comes from Article 210.52. If you check that code reference, the heading of that article is dwelling units. So everything I'm about to talk about only pertains to residential dwelling units. These spacing requirements do not apply to commercial installs. They may throw some trick questions at you at some point. Hey, how far apart do my receptacles need to be in this bank? Well, there's not really a requirement, and these requirements don't apply. This is dwellings and residences only that we're talking about. So first of all, the receptacle spacing is broken into 2 categories. We have the general areas, which is basically your living rooms, your bedrooms, your things like that. And then we have kitchen counters, which are kind of its own special entity. We have to basically shrink up all of our measurements and our spacing for that. But to begin with, let's look at the general areas, right? So there's the way that the code is kind of written here is no wall space can be more than 6 feet from a receptacle. And the way that I think about that is if you take a floor lamp with a 6-foot cord on it, if I place that at any point on the floor, if I go 6 feet in one direction or the other, I need to have a receptacle within 6 feet. And that's kind of why the code's written that way. But another way to say that is down here where it says receptacles can be no more than 12 feet from one another. Those 2 sentences, this one and this one, are essentially equivalent. They're both saying the same thing. My receptacles can be a maximum of 12 feet apart, or no wall space can be more than 6 feet from a receptacle. If we look at that, let's look at this spot right here, right? These receptacles are obviously 12 feet apart from one another. If I put a lamp with a 6-foot cord dead center in here, and I go, obviously half of 12 is 6. If I go 6 foot this way, I hit a receptacle. If I go 6 foot this way, I hit a receptacle. But what happens if I put my lamp over here? Obviously I can't, this is now more than 6 foot going this way. But if my lamp's sitting right here, it can reach this one. So no wall space is any more than 6 foot. I can pick any space arbitrarily right in here and go 6 foot in one direction or the other, and I will hit a receptacle. So that satisfies this code. That's the way the code's written. However, we can see in reality that means my receptacles are within 12 feet of one another. As long as they're within 12 feet, I've abided by the code, right? And the thing to note is that spacing actually wraps around a corner too. It doesn't stop or it doesn't start over. So if I look at this receptacle to this receptacle, I go 6 foot this way and I hit the corner, and then I keep going another 6 foot. That's where my receptacle has to be. And obviously these dimensions could be smaller than this. This is the largest they can be, but again, I can put that lamp dead center in the corner. I go 6 foot here, I hit this receptacle, 6 foot here, I hit this one. Or if I decide to put that lamp right here, now I can hit this one within a foot or two, even though I can't reach this one. That's not a problem. I've got this one here to cover it. The other thing we should mention, a door essentially breaks up your wall space. So here, if I measure from the door, I can only go 6 foot till my first receptacle, right? I can't go 12 feet from the door to the first receptacle, because if I'm 8 foot away from this receptacle, I now don't have a wall space within 6 feet. So again, I can pick any wall space in here arbitrarily. If I go 6 foot in one direction or another, I need to hit a receptacle. Well, since I don't have one over here, this can be no more than 6 feet. The other thing to mention, any wall space 2 foot or greater requires a receptacle. So do we need a receptacle in this little space right here between these two doors? Well, in this case, it's only 1 foot 10 inches, so no, I did not. If this were 2 feet or larger, I would in fact need to put a receptacle in there. Okay. So when it comes to, so again, that's your general areas like your living rooms, your bedrooms. When it comes to kitchen counters, the exact same logic applies. We just have to shrink those measurements a little bit. No wall space can be more than 2 feet from a receptacle, whereas before, no wall space can be more than 6 feet. Or another way to say that, receptacles can be no more than 4 feet from one another. And then any wall space that is 1 foot or greater requires a receptacle. So same exact logic, same exact principles. It's just that the measurements are a little bit less. So again, that's not everything you're going to see on the test, obviously, but those are sort of the high-level topics. If you guys can master them, I think this exam should be a lot easier. This is broken into 3 parts. You don't necessarily have to take them all at once. That's why it's broken up that way. But again, I encourage you to take your time. It's kind of a long test. It covers anything we've covered so far in the curriculum is fair game. So anything from lesson 101 all the way up to lesson 110 could be in there. So again, take your time. Good luck, and hope you do well.